Okay, well, thank you everyone for coming. My name is Montague. I'm a new PhD student at University of Vermont with the co-op unit. And my advisor, he's Dr. Mark Henderson. So I'll be talking about the acoustic telemetry of Atlantic salmon smolts in Lake Champlain. This is really a pilot project that we started this last spring, and hopefully going to get some preliminary data pretty soon. I'd just like to first start with some acknowledgments. This is a very collaborative project. Actually, let me go ahead and go like this. I first just like to thank the University of Vermont Cooperative Unit, where I'm working under, especially my advisor, Dr. Mark Henderson, and then all the people that helped out with field work and data collection for this pilot project. I'd also like to thank the Vermont Fish and Wildlife, the state agency, the folks in the Essex office, and also the Edweed Fish Culture Station have been really important and really helpful on collecting the data, but then also at Edweed, where we actually tagged these fish for this study. And then finally, Lori and Kurt with the U.S. Fish and Wildlife Service. They've been super helpful and really have guided me throughout this little pilot project, and I'm excited to work with all these collaborators in the future. This is a great team of people, and hopefully we're going to learn a little bit more about some juvenile salmonid movements throughout Lake Champlain. All right, so like we've heard before, a lot of talks have talked about this, but landlocked Atlantic salmon were extirpated from Lake Champlain in the 1800s. This is really due to overfishing, spawning habitat loss from dam construction, and also habitat degradation. So really, they were completely wiped out of Lake Champlain. Luckily, we began to reintroduce these Atlantic salmon through stocking efforts back in the 1970s. We really wanted to stock them to create a recreational fishery for anglers to go out and enjoy catching salmon. However, we're seeing limited observations of natural reproduction throughout the Lake Champlain Basin, which is problematic despite the high stocking efforts. We also see a truncated age structure, and this is based on our salmonid fall sampling surveys. So a lot of the Atlantic salmon that we're actually seeing in these surveys have a truncated age structure, and the majority of them are released the previous spring as smolts. So when we sample in the fall, those fish were really just released that previous spring. So this kind of just leads us to a couple questions: are there high mortality rates at different life stages throughout the Atlantic salmon? And really our goal is to develop a life cycle model so we can manage these fish better and learn a little bit more about their life history. However, to develop this life cycle model, we need more information on juvenile salmonid habitat preferences in Lake Champlain and also their mortality rates. So this really kind of leads us to our pilot project that we started this spring, with the objective is to observe the movements and regional habitat use of Atlantic salmon smolts during their first year, so roughly 365 days, in Lake Champlain using acoustic telemetry. And really the objective of this study is going to lead us to understanding early life history and specifically the habitat preferences and also their seasonal movement patterns throughout Lake Champlain throughout that first year. So the way that we're going to do this is we're going to use acoustic telemetry. And if people don't know what acoustic telemetry is, we put tags in fish that send out a signal, and there's receivers positioned throughout the Lake Champlain, that pick up that signal of that tag, allowing us to look at and track the movements of those fish. So we're going to utilize the already existing receiver array of the Lake Champlain Acoustic Telemetry System, or CATOS is what we call it. And CATOS is an existing array with Innovacy receivers. The majority of them are the VR2TX receivers. There's roughly 60, give or take. We're planning on putting additional receivers out. But these are 69. These operate at a 69 kilohertz, and they're positioned lake-wide. So a majority of the basins throughout Lake Champlain have these, so we could observe the fish movements. There's other fish throughout the lake that are tagged too that are also giving out signals, not just Atlantic salmon now, but lake trout, and past studies have looked at lake trout and sturgeon. And like I said, we plan to add additional receivers to get additional coverage on places that are undersampled and don't have a ton of receivers. But if we just look at the picture real quick, the receiver is, you can see, anchored on the bottom of the lake. So these are throughout Lake Champlain. It's suspended with a buoy. And then we go out and we service the receiver. So this is collecting the data that the Atlantic salmon are actually pinging, or other fish that are actually tagged, but they're pinging, and then these receivers take that information in, and then we could observe their movement patterns throughout the lake. The thing about with these is we do have to service them. So this coming summer, I will be out there and actually collecting the data on the movement of these fish. Okay, so now for the tagging side and the surgery side of the project, we tagged 50 hatchery arrays, Atlantic salmon smolts, with acoustic transmitters. The acoustic transmitters we use for side reference, this is my hand. They're pretty small, they're about 20 millimeters long. These fish were reared at Ed Weed Fish Culture Station. So all the fish that we tagged were from Ed Weed. We used V8 acoustic transmitters, and these had a battery life of 406 days. This is actually a pretty long battery life for these tags, so we could observe their movements of these fish throughout over actually a year, as long as the battery life holds up. And it's at a ping rate of 180 seconds, so they're sending out a signal about every 3 minutes. And then we also held these fish post-surgery for about 7 days, and then before they were stocked, to observe post-tagging survival of these. But if we look at just a juvenile salmonid, the whole idea is that you make a small incision in the belly of the fish, and then you implant that transmitter, suture it back up with some surgeon's knots, and it should be happy and healthy and survive. We also did 10 dummy tags. Dummy tags are pretty much replicas of the actual tags. The reason why we did this is we wanted to look at the effects of a longer term effects of the tagging. So we held the dummy tags for around 30 days post-tagging to see if there's any post-tagging delayed mortality associated with the surgery. We also did 20 control fish. 10 of those fish were surgeries with no tags. We wanted to see if there was a tag effect to our surgery. And we also had 10 just untouched fish. So we just held them within the hatchery raceway and observed to make sure that they're all happy and healthy. No fish are dying because of the surgery process. The surgery protocol that we followed was from Leideke et al. It's pretty much a culmination of surgery tagging protocols that the USGS puts together. And the whole idea of pretty much the process of the surgery is that we use aqueous to knock the fish out, so they're anesthetized, so we could handle them so they're not stressed out. We then take their length and their weight, so that's kind of some of the biological data that we're actually getting from the fish. But we also look at the surgery time, so how long it takes for me to conduct the surgery, and then also their blood levels. So when we make the incision, is that fish bleeding excessively or not bleeding, and hopefully help us tease out which fish are going to die or survive or die during the surgery. And then we held them in the race ice, like I said. So we held these up to 30 days, at least 7 days post-tagging for the actual fish that were stocked. So now we move to the stocking and the tracking portion of it. So we picked 3 different stocking locations. Ed Weed stocks, I think, around 16 to 17 locations lake-wide, but we picked 3 different locations to actually put our transmitters, so our fish that we actually tagged. We stocked at the Lamoille River with 15 transmitters, the Missisquoi River with another 15, and then off the ferry Charlotte, just right into the open water with 20 fish. And this was all Ed Weed stocking that was doing it. Again, we're utilizing the Cados receiver array. So where we stocked, we do know that there's receivers to pick up on the fish that were first initially stocked, but to also increase our understanding of where they're moving initially and also that they're surviving the stocking process, we also conducted some manual tracking using a VR100. This is the VR100 unit. You put a receiver off the boat and you kind of listen for those tags. So pretty much you're that mobile receiver, making sure that you can see where these fish are actually moving. And then the way that we did this is we created some sampling grids. So if we look at some quick maps, I know this looks a little bit small on the screen, but Lamoille River, we stocked 15 fish within the river. You can see the circle, the red circle, that's the receiver range. So we stocked these fish within the river, and to get to the main lake, they have to go past that receiver. So they're also picking up data, but while we track, we're also tracking within the river based on those sampling grids. If we look at Ferry Charlotte, again, this is off the ferry. So there's receivers located near the ferry, and we also did mobile tracking around those sampling points on Ferry Charlotte, and then Missisquoi River, the same thing. If the fish traveling downstream into the Missisquoi Bay has to go past the receiver, making sure that those fish actually survive the stocking process. All right, so if we talk about just some quick preliminary results, we were able to successfully tag the 50 planned Atlantic salmon smolts. So all those survived the tagging process, which we were really excited about. And they all survived up to 30 days for our control and our dummy tagged fish. Based on our dummy tags and our control fish, I was able to cut them open and observe the incision to see how it's healing. Sometimes with acoustic surgery, with surgery processes, the healing can be rough and lead to delayed mortality, but this was healing up very nicely. You can see the incision with the two small sutures still there, and you can barely see the tag there. But this is also another fish that survived the 30-day holding period, that healing up nicely, that those sutures are nice. So we're excited about that, and hopefully those fish are still swimming around in the lake. We also had successful stocking at the 3 proposed stocking locations, which we were excited about also. And for our manual tracking, we didn't see a ton of fish, unfortunately, but we did get some detections. So in the near Ferry Charlotte, we had one detection down by Otter Creek. We had one detection of a fish near the Lamoille River, actually in the Lamoille River, and then no detections in the Missisquoi River. So with the river stockings, this is actually encouraging because it means that most of those fish actually did get out to the main lake and they're swimming around the main lake. At least that's what we're assuming based on our manual tracking. We'll have to check the receivers within the river to make sure that's actually true. But yeah, we are excited about seeing some detections. So for our future research and what we're kind of planning on doing in the future, in the spring, in this later spring and in the summer of 2024 this year, we're planning on doing caddis retrievals. So all of the receivers lake-wide have to get serviced. So we'll go out and we'll collect the data based on all of these receivers. And this is going to give us some preliminary movement data on the Atlantic salmon smolts. This is exciting because this is the first time we really kind of have an understanding, well, we'll have a little bit of an understanding on where these smolts go after stocking. This is the first acoustic telemetry study of the Atlantic salmon smolts. We're excited about the preliminary data that we're going to get. The nice thing is that we'll get data, the full data next year, next summer too. So it'll be cool to see where these fish are actually moving. Then in the spring of 2025, we plan to tag additional fish. This time we didn't use any predator tags, but there's also tags out there, acoustic transmitters, that can tell whether or not that salmon smolt was actually eaten and digested by, say, a lake trout or a pike, another piscivorous fish. So we're planning on incorporating some of those predator tags into the fish that we stock next year. We're planning on going back and stocking and tagging additional Edweed Fish Culture Station reared fish, but also incorporating the Dwight D. Eisenhower National Fish Hatchery fish too. So really understanding, more stocking locations and really the survival and movement of these fish is going to be super important. But yeah, so this is pretty much the map. If everyone was curious on where the caddis receivers are, again, stocked down in Ferry Charlotte, Lamoille River, and the Missisquoi River at a good spatial extent on where these fish are actually going to be moving. But that is all I have for everyone. I'd love to take some questions though.
What depth are you putting the receivers at?
So the receivers are at all different depths. It really kind of depends on the receivers. I think we have some receivers that are 350 feet down some receivers are very deep. I think the average, I think I just calculated, I think the average depth is probably 60 to 70 feet per receiver, but it's very dependent on the receivers. We have shallow receivers, deep receivers, mid-water receivers, but the bottom line is it's a little bit of everything. If that makes sense. But the nice thing about this, I will say, if we talk about the positions, while say in the inland sea we don't have a ton of receivers, we do have the pinch points covered. So if a fish does plan to get into the inland sea, we do have those pinch points covered. So say if a fish was stocked in Lamoille and he's going up to the inland sea, we know they're going to hit receivers either way from up north and down south. So there is points where those fish can get detected. Based on the preliminary results that we get this summer, we can then come back and add additional receivers if we think that there are a ton of fish are in the inland sea or vice versa, wherever we have lack of coverage. We can then put additional receivers. And that's the plan. We plan to purchase additional receivers and put them where we think we need them for the movement for next year. Yeah. All right. 2 questions.
Where's the range of receivers?
So that's a good question. We haven't done any range testing quite yet. So the receiver gets in the ping, so it's actually the tag is what is the range. So how far the tag pings is really the range of it. But these tags from the literature can go up to 1,000 meters. It's very far. We don't know if Lake Champlain quite yet. We still got to get range testing tags that we'll put, and we'll do a range test. So the way that range testing works, you'll have a stationary receiver, and you put the tag, a certain area from that receiver, and then you can kind of get how far that's actually happening. But in the literature, it's up to 1,000 meters, which would be awesome. I don't know if it's going to be that far in Lake Champlain. Any other questions? They're great questions. I really appreciate it. We're excited about the project.